hyperpolarization is when the membrane potential of the neuron actually becomes more negative than the resting membrane potential. So this is the point here, that curve there that comes in is because of hyperpolarization. And this hyperpolarization, it is what makes the neuron to not fire another action potential again immediately. Okay, so it makes the neuron to be more negative, and that means that if you are to really stimulate it, it needs more intense stimuli. Okay, so effectively, it basically prevents the firing of action potentials when the neuron is not yet ready. So that means that it controls the timing of firing of the action potentials, the timing and the frequency. So how does it happen? It happens because you have an influx of potassium ions or an influx of chloride ions. This happen because the sodium channels have actually been closed. So remember, when you have an action potential, sodium ions are opened, and then sodium ions enter in, cause the neuron to be positive inside. But when an action potential has been generated, then the sodium ions are closed, and then you have potassium ions coming in, including the chloride ions. And these are the ones that are responsible for the hyperpolarization. But also, you can have other chemicals, for example, what we call inhibitory neurons. These ones can be released by synapses or what we call presynaptic membrane to inhibit the transmission of an impulse. So that means that they basically inhibit action potentials by making the postsynaptic membrane more negative than it should be. So GABA can be one of those that can activate the receptors that increase chloride permeability, and this is what contributes to that more negative neuron. Okay, so if you have the inside of the neuron becoming more negative, it becomes very difficult to reach the threshold value to cause an action potential, and that's why hyperpolarization basically inhibits the propagation or the initiation, basically the initiation and the eventual propagation of impulses, and that's why it basically it governs the timing and the frequency of impulses that are fired. Okay, so hyperpolarization makes it less likely that the neuron will fire an action potential, and this means it controls the extent to which these neurons get excited and prevents excessive firing of action potentials. It is this hyperpolarization that contributes to the refractory period, a phase in which excitability of the neuron is actually reduced, okay, almost to zero. And we'll see that basically we have two types of refractory period. But before we go to that, refractory period is that brief period, less than a second actually, between 1 to 3 milliseconds, where after an action potential, you cannot have another impulse or another action potential being generated along the neuron. Okay, so that means the benefit of that is that you don't have this quick firing, uncontrolled firing of impulses. That's one. But the other thing, it ensures that you have impulses moving in one direction, as we shall see later on in the properties of impulses. We'll see that impulses are transmitted unidirectionally. So it only moves. This refractory period allows impulses to move only in one direction. That's the forward direction. Okay, that means that it cannot allow the previous segment to again get depolarized. So we have two types. Absolute refractory period, when you cannot have any impulse being transmitted regardless of the intensity of the stimuli. And then with the relative, it means you can fire the electrical impulse, that the intensity has to be more, because the threshold, to reach the threshold, you need more stimulation or more intensity. Okay, so those are the two types of refractory periods. We now look at what we call the all or nothing nature of action potentials. This is one of the properties of action potentials or nerve impulses, is that if the stimulus is of low intensity, it cannot result into a full action potential unless the threshold has been reached. Okay, so if you have not reached the threshold stimulus, then no action potential will be produced. Okay, so sub-threshold stimulus, no action potential. As long as you reach the action potential, that's when you can have. As long as you reach the threshold potential or value or stimulus, that's when you can have a full action potential. That means that the intensity of the stimulus is very important to reach the threshold potential. And the other thing is, increasing the intensity of the stimuli does not increase the size of the action potential, but